Not recording. Yeah, okay. Now we have it. Forgot completely. Let's see. So those are the things that you have to work out. So, what I'm gonna do, uh, report for lab one is due next week, okay? No, next week is gonna be the exam, so I'm gonna skip that. It's going to be due, okay, 11th, okay? Report lab one due. Let's do this way, right? Report lab one due. Okay, next week is the exam, so I usually don't make the lab report due on the exam, so you can have as much time as you can to start to study for the exam, right? So it's gonna be due next the following lab, October 11. To October, 2 weeks from now. Now let's see group number 2. How are we doing there, group number 2? Yeah, group number 2 still didn't put the spreadsheet there yet, right? We're looking at group number 1. So group number 2, what's that? So Ridwan, did you manage to finish the spreadsheet? Ridwan and Annabelle. Hello, folks. Can you hear me? Okay, I cannot hear from Ridwan. I cannot hear from Annabelle. And okay, so let's skip here. Let's go to group number 3, right? Group number 3 managed to finish to upload their group folder, their group report. And that's the one here. Let's see how they did it. Okay, enable editing, good. Okay, everybody's here. Yeah, you can put today's date, okay. Group number 3, 27, right? And let's see, 222, 333, blah, 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 444, right? So you do have it. Okay, good. 3 sequence digits, 4, 2, 3, 4 sequence digits. Good. Here is going to be 5 decimal places, right? This one has 4 figs, 3, 3, 4, 4, 4. Okay, so that's good. And I don't see anything. What about here? The graph. Okay, those graphs, I can see the numbers more easily. And here you go. R square and the regression equation are there. Good. Yeah, it seems to be optimized. The space as well. That's good. And yeah, this one here also looks like it's optimized, right? And what about, okay, what about the axis title are missing, right? Axis title of those two graphs. And then we have the other one here. Gonna put the axis title here. Most seems to be in good shape. I do not know if the CL is correct, but most likely it is. Right? and then you got all those percentage differences. Good. So here you go. The percentage strokes through, right? So streaking through, right? Let me check that to font. Okay, strikes through. So now looks nicer. Okay, so the only thing that I see here, group 3, is oh, you cannot put the kilogram cubic meter here, right? The kilogram cubic meter is already here. Don't repeat it here. Okay. Now, how did it manage to calculate the percentage? Ah, because you calculated. You erased my formula. You calculated, right? Okay. Okay. So erase. So let's list here. Do not repeat group 3. Group 3. Okay. Do not repeat the unit in the cell where the number goes. Okay. Do not put the unit there because the unit is already in there. The unit is already here at the top. So if you repeat the unit here, you're telling me that this number has a unit of kilogram square meter to the 6th power. That's what it means when you repeat this unit here. Okay, so the right way would be to erase that. You can change the format, okay? Format, in number format, here you go. And then once you have that number, then you can preserve that formula that I had here. The formula that you erased, right? And the formula calculates exactly what's going to be the percentage difference between those results that we got. Okay, so let's go back to this one here. Sig figs for the math looks good. You don't have this problem. Must be 3 graphs. You do have 3 graphs. X title are missing. X titles of 2 graphs are missing. Font size 12, I didn't see a problem with that, right? Let's take a look. Let's see if font size is 12. Ah, it's 9. Okay. Yeah, increase the size. Okay. Yeah, increase the size of the font, please. The other ones should be 9 as well. Yeah. Please increase the size. Let's see here. Use font size 12 for the graphs. Font size 12 or greater, right? The graphs. We do have R squared there. Yeah, you put this R squared, you have the CL. Okay. And the other one that I recommend, do not erase the equations in the spreadsheet. Okay. Do not erase the equations in the spreadsheet, right? If the spreadsheet is not displaying a number in there, that's because there's something wrong that you did, right? Do not. Sorry about that, but I just got to go too far. Okay, good. Thank you, Ridwan. Okay. Okay, so let's take a look at group number 2 now that group number 2 is back. Let's refresh here. So group 2, download. Okay, so here we go. Okay, number, that's good. No problem there upstairs. Third decimal place, fourth decimal place, fifth decimal place, right? Okay. Three decimal places, but two significant figures. So we have two here. Four decimal places, but three significant figures we have here. 3, 4, 5 decimal places, but four significant figures. Good. We are in good shape here and here. What about here? We must have 5 decimal places. Good. No problem. The units are okay, are correct. And good. Okay. I suggest that you don't put the parentheses here for the V, right? There's no need to do that. Okay, and we can, I see everything here. Let's see. Mhm. Okay, and the equation is here. Yeah, the equation is here. Okay, all right. And here, see that? This number here is part of the equation right in here. Everything is highlighted, right? This one is highlighted, this one is highlighted, right? And so, okay, so it looks like this group did pretty well. It looks like, okay. I have no, well, maybe the only thing here that I would say is the font size, right? Group number 3. Oh yeah, the axis title as well. No axis title here in the vertical, no axis title, no axis title in the vertical, right? So, and you can cut down some of those zeros here. You can cut down some of those zeros so it doesn't look like too busy. This one you don't have to worry about. Here, you can cut down some of the zeros in the graph, right? So group number 2. Group number 2, copy, paste. Sig fix for the volume of the root. Okay, that's not the problem. This is not the problem. Must be 3 graphs. Okay. Axis title are missing. In the vertical direction, right? In the vertical direction. Use font size 12. Don't forget to put X title. X title, axis title, right? Should be font 14 or larger. Font 14, but not too large, right? Otherwise, it's gonna be larger than the graph. You don't want to do that. Font 14, bold face, okay? Bold face or larger. Or larger in bold face. Every time that I'm preparing a report, that I have to put graphs in there, patents, report, papers that I publish, I'll go through all that stuff, I make my graph look nice, make sure that the font size of the numbers along the axis are large enough. I prefer to have the title of the axis in boldface. I always make the title larger, the axis title larger than the font of the numbers as well. Miss size 14 on this type, but it did bold. Oh yeah, okay, good. Okay, so that's for everybody else. Thank you. 14 or larger. Use font 12 for the graph. What else? And group number 2. Oh yeah, the too many zeros, right? Too many zeros. And minimize the number of zeros that show up in the axis. Okay. the number of zeros. Wherever you can, right? Wherever you can, you can eliminate this zero. Here, yeah, here you can eliminate 2 of those zeros, right? You don't want to eliminate 3 zeros because then you're going to have a problem distinguishing numbers, right? Instead of 5 decimal places, put 3 decimal places, okay? If I put only 2 decimal places, what's going to happen? I'm going to have the number 5 repeated here because the axis is, the program is what the program is doing. The program is, I'll remember later on. Yeah, but you know what I mean, right? The program is he's treating 0.045 as being 5, right? That's what's happening. So that would be a better number. And here too, we have too many decimal places. Okay, I would accept, for instance, just 1 decimal place. I would accept, right? Just 1 decimal place I would accept. But if you think it's too large, you can go to 0 decimal places. Okay. And here too, the same thing. Too many zeros along the axis. Okay, and let's see, who else? Group number 2, group number 3, group number 4. Okay, so I already have Marco Sanchez here. Let's see, Marco Sanchez, how is download? Group number 4. Okay, no units here in the cell, right? And 3 decimal places, 4 decimal places, 5 decimal places. Do I have 5 decimal places here? Yes, I have. 2 significant figures, 2 significant figures, 3 and 3, 4 and 4, good. Okay, I don't see any problem here in this table. The units should be right as well. Okay, this table filled up. And good, so let's take a look at this graph, right? Yeah, so one thing, right, you can bold face. Oh, I got enabled BT here, good. Yeah, you got a, bold face here. If you have a little bit, don't put capital M, right? Don't put capital M. It should be lowercase m. If you have some time, go ahead and upper script, superscript this number. Also bold face it, right? Okay, let's see. Yeah, and size is 12, a little bit small, right? Like I said, this one is 12 as well. This one is 12 too, but make it 14 at least, right? Always make the axis title larger than the numbers here. So we know there are too many zeros right here. Let's document that. Oh, group number 4. Number 4. Okay, you didn't have any problems with the significant figure of volumes. You didn't have any problems with the figures of the mass. You have all the 3 graphs there, right? Ax title are missing. Let's see. No, ax titles are not missing, right? So we don't have any problem here. Font size is font size 12 for the numbers, right? For the numbers in the graph, right? Did you do that? For the numbers in the graph, yeah, you did, right? For the numbers in the graph. Font 12, good. Font 12 or larger, right? Or larger for the numbers in the graph. So that's not a problem. Okay, another video. Good for the graph. Numbers in the graph. or the numbers in the graph. Okay. Okay, we didn't have any problem about this one. What about 14, right? X title should be from 14 or larger. X size should be from 14 or larger. Larger than the numbers. And bold-faced, right? And bold-faced. And bold-faced, yeah. Okay, this one too. Okay, too many, too many zeros, right? Too many zeros. Let's see who the table. Minimize the number of zeros that show up in the axis. Minimize the number of zeros that show up along the axis, right? Along the axis. When I say minimize, it should be optimized, would be right. Yeah, should be minimized. Minimize without losing any information, right? Any information. Minimize the number of zeros without losing any information. Without losing any information. Would be like that. What else did I pick up there? Okay, good. Oh yeah, see, very important, right? You do not want those numbers encroaching on each other. You don't want that. Okay. Okay, and how do you do that? You either decrease the numbers of zeros there, the number of decimal places. Let's put just one. Ay. He didn't update it. Well, okay, now he did. Sometimes a little bit slow, right? Oh, capital M, right? Use lowercase m for meters. Use lowercase m for meters. Okay, capital M means what? Capital M means mega. Okay, capital M means mega, not meters. 10 to the 6. Okay, so that's what I see for group number 4. And now I can update. Let's this one here, group number 4. Yes. Let's see, Alexis is here.
Oh, Professor, I'm sorry, I'm here.
Yeah, you're there?
Yes,
okay,
Camden is
okay,
here.
thank you, Camden. Okay. Okay, and how many students we have? We have 13 so far.
I'm here today, Professor.
Is that?
Eric Martinez.
Eric Martinez. Okay, right in here. Okay, here we go. Now we have 13. And 4, right? And then last but not least, right? Group number 5. What time is that? 9:46. Okay. Download. Okay. Don't forget the mistakes that other groups make, You can learn with the mistakes that other groups make as well, right? So let me close everything here. Otherwise, it's gonna be difficult for me to keep track to navigate. You don't want lots of windows open, right? Because it makes a challenge. It's kind of challenging to navigate in a computer screen that has so many windows opened. Okay, and now I can open the other one, 5. Okay. Okay, 3 decimal places, 4 and 5. Simple enough, right? Okay, we have to have this concept of decimal places, number of decimal places, and we have to have this concept of significant figures and understand the number of significant figures is not the same as the number of decimal places, right? Not necessarily. Sometimes the number of significant figures coincide with the number of decimal places. But whenever something like that happens, it's just coincidence. Okay, now we have 2 significant figures. We are supposed to have 2 significant figures here, right? Instead, we have 3. So we have 3 here. We are supposed to have 3 here, right? There's only 2. Here we have 4, and here we have 4. That's good. 1, 2, 3, 4, 5. Okay, significant figures for the volume, for the ruler and vernier caliper volumes. Group 5. Let's copy this one, right? Of the ruler and vernier caliper. And vernier caliper for the volumes, right? Of the ruler, good. Significant figures of the mass, we don't have a problem with that. All right, all the units looks good. Oh, and now we need to, right? You need to fill up table 0.2, right? So let's see. Table 0-3 missing. Oh, and almost every is everything, right? Table missing the following: n, regression equation, r squared, and CL. Okay, do we have? Let's see the graphs now. We have the graphs, but it seems to me that the font size is too small. Is that small? Let's see, font. Yeah, the font size is too small, right? This one too here. Font size for the numbers is too small, and font size for the mass is too small as well. Okay. And in the graph, since it's a graph, it's better if you use the upper script for cubic meter, right? So going back there to the table must have, okay, 2 graphs are missing. No, this one, all the 3 graphs are there, right? 1, 2, and 3. Where's the other graph? Yeah, I don't see the other graph. Okay. Okay, group 5, I don't see the other graph, right? So this one is for the ruler. This one is for the vernier caliper. Okay, graph for the micrometer is missing. Okay. Graph for the micrometer is missing. Micrometer is missing. Use, okay, we didn't have any problem. Use font size 12 or larger for the numbers in the graph. Use font size 14 or larger for the titles, for the axis title. Okay. You make it bold-faced. Yeah, you made bold-faced. Yeah, let's add that. For use superscript, right? Use superscripts for the unit. For the units. when necessary. Okay. Anything else? Yeah, gotta fill up the slope, right? The slope for vernier caliper. Oh, plus the units. Slope values for the vernier caliper and micrometer. Okay, and there is also units, okay? Units in the last table. So I got my graph into drive. Okay, your group 5. Okay, that's the one we are looking at, right, Eric? That's the graph we're looking at, right? Okay, good. So unless you dropped another one, you didn't drop the second. Oh, you dropped the second one, yeah. You dropped the second one. Okay, so download. Let's see. It's 9:53. You should go for a break, right? Let's take a look here at this. So I'm going to correct all the stuff. Like I said, yeah, don't forget the axis title now, right? Now the axis title I'm missing. Yeah, the numbers are encroached, right? And I don't see the equations. Yeah, I think that the first one was better than this one, okay? Here you put too many sequence digits. Do you see that, Eric? The first one that you uploaded is better than the other one. Okay. Oh, wow. Ooh, okay, good. Let's take our break now. 9:53 right now. Thank you. Okay, break. Yeah, I need to talk about the exam, right? When we come back, we talk about the exam. Break. 9:55 a.m. to 10 a.m. Okay. Oh, wow. Okay, good. I'm going to stop here sharing the screen, and I see you in 15 minutes. Okay, we're back here. 10, 11. Okay, so now you should be able to master the spreadsheet, right? Now you should be able to master the spreadsheet for every lab. Every lab. And let's talk about the exam, right? The exam next week. It's a good thing that I. Okay, so how does the exam works? Next week. Well, we will next Wednesday, right? Next Wednesday, we will have our exam. We will have our first exam. And let me see here. I didn't write that down here. Okay. The material I posted, right? I posted there in the website. The material for the exam should be first exam. The material will be, sections 1.2 and 1.3 units, right? Dimensional analysis. And all sections 2.1 through 2.7. We covered 2.6 last time, and lab 1. Everything from the textbook, from the notes, right? From the homework, not just the textbook, but whatever we covered in the notes as well. Okay. Lab 1, everything we covered until today, minus, right? Vectors, excluding vectors. Excluding vectors. Rely on the material of the textbook. Notes, right? Lecture notes, lab notes, and homework. Textbook, okay? Lecture notes, lab notes, and homework. Covering today, excluding vectors. Have covered until today, excluding vectors. Let's check the yeah. Okay. So I posted this notes, right? As a reminder, the first exam was postponed to October 4th. The material for the exam is going to be everything we covered until today, excluding vectors. And it's not just the textbook, but whatever we cover here in the classroom as well. Okay. Oh, and what else you have to know? Okay. The exam, to do the exam, you must have simultaneous access to Canvas and Zoom, and this Zoom link, right? So during the exam, your webcam must be on. It must be on. During the exam, your webcam must be on, right? So what you're going to do, you're going to get into Canvas, no big deal, right? And you're gonna click in the link for the Zoom link with your camera on, and I'll be watching you, okay? So the exam will start at 8:50 and will end at 10:50 a.m. Okay, 8:50 a.m. will end at 10:50 a.m. Then we can take the day off after the exam, so we can decompress. Okay. Once you finish the exam, send me a chat message. Don't forget, you must be logged, okay? You must be logged into the Zoom. If you're not logged into the Zoom link, if I don't see you in your webcam, you won't be able to do the exam. Okay, you won't be able to do the exam. So if you are not logged in the Zoom link and I cannot see you in, right? Or this you must, okay, here you go. You must be logged into the Zoom link into the Zoom link and must have your camera, webcam on. Otherwise, you will not be able to do the exam like that. Okay. If you don't have a working webcam in your computer, you can use the camera in your cell phone, right? Make sure you have a reliable computer and internet connection. Okay, I also advise you a reliable computer, internet connection, and a UBS in case your power goes down. So these UBS devices are sold. Those are amazing devices that they sell out there. I just discovered them recently. Okay, if your power goes off there at your home, this thing is a backup electricity power source. You can connect your computer and your internet modem into this UBS. I mentioned that before, right? And while you don't have power in your home, the UBS will provide you power for 2 years, something like that. 2 years. Oh, sorry, 2 hours, right? Maybe even more, depending on the model that you have. It's one of those amazing things. When I'm here at home, every now and then the power, I have a brownout here. The power goes momentarily off and comes back immediately. And I have this UBS device here. If I didn't have the UBS device, I would lose my connection with you folks. And it would take a long time for me to connect back with you. It happened. It happened to me when I was teaching. A long time means like 5 or 10 minutes, right? That's what it means, a long time. The power just went momentarily off, just for a fraction of a second. But then it took me 5 to 10 minutes to connect back. And by the time I connected back, the students were gone, okay? And now that I have this UBS device, it's, I don't have this problem. Every now and then the power goes off here at my place, and I still talking to you, right? I still have internet. I still have electricity to my computer and the UBS and the modem. Let's see. Let's take a look at UBS. UBS, no, UPS, right? UPS power supply. Here you go. It's not UBS. It's UPS. Uninterruptible power supply. Okay, that's what. Let me correct that. Ridwan News chose UPS, right? He didn't say anything. Go. UPS. Okay, uninterruptible power supply, and uninterruptible power supply. Okay, this is a smart device. This is the pricing in Brazilian reais. Okay, if you divide by that by five, but United States is cheaper than that. It's cheaper. Let me see if I can get a price for maybe Best Buy store must have something like that. Best Buy. Now there are so few electronic stores, right? Brick and mortar electronic stores. Here you go, Amazon. Power backup for PC. Here you go, Amazon. Basics, UPS. But they don't tell us what is the price. 59? No, this wouldn't work for your computer. But this looks like it would work for your computer. Okay, gotta look at how long those things would power. Mine is not 1,000 VA. Mine is more like 15,000 when I bought it. It's more power. VA is the unit of power. Let's take a look here. 700 VA from $195. See, that's how much it costed, $195. But 1000 VA, I don't see it lasts very long. Okay, gotta look at the specs of this device. Do you know how long it lasts? This one, 1000 VA, read one must know it, right? Do you have any idea? Let's see if it's there. The packaging usually says how long something like that lasts for a computer, for a modem. 8 outlets, 600 watts battery backup power supply, automatic voltage. Yeah, it doesn't say.
Professor, I have a question.
Yeah,
Do you
go
have
ahead.
to charge this device to use it, or?
You mean the UPS?
Yeah.
Well, the way you do, you buy something like that, you go home, connect to the electricity, right?
Mhm.
And while you're doing other things, it's charging
Oh,
this device. And then when you connect your computer to this device, has a bunch of outlets in there, it looks like this one has what, 8 outlets? I read it. Plus, where is that? And then, since it's connected directly to the electricity, it becomes charged, right? After a few hours. And then whenever comes the exam, it's already fully charged. Okay? If the power,
okay.
but don't forget, once you do that, I highly recommend it. It's, man, I'm so happy with my UPS device here. Let's see. It's that's why I highly recommend it. Any brand name that you're familiar with, I wouldn't say any, I wouldn't recommend a specific brand name, but anything that you are familiar with. I have one small here. Let me check. Yeah, I don't have the specs here. It's not available, the specs of mine, but yeah, it's something that you connect to the electricity, right? And then the device itself has power outlets. And then you connect your computer and your modem to the outlet of the UPS device. Don't connect directly to the electricity, right? Use your UPS as though is an extension cord of your device. So if the power goes off, you still have some juice there inside this device, which, by the way, has a battery. Okay, backup UPS. Okay, but look at the pricing. That's ridiculous. $200. It's mine.
Mhm.
Mine cost me more. It cost me like $400. But I bought here in Brazil. So Brazil is more expensive. Electronic devices like that. And then you have other C8 outlets. Oh, but that's not a UPS. Okay, yeah. Oh, yeah, it's UPS. Okay. Yeah, it's a UPS, another one, 8 outlets. Has even, yeah, that's how this one is how much? 69, but also is a lower power device. See that? Has less juice in there. Okay, and you can, that's what I recommend, okay? And let's go back here to my UPS, uninterruptible power supply in case your power goes down. And look at the specs. Look at the specs of the device once you go shopping. Okay, how long it holds, Connect your modem there, connect your computer, connect your monitor screen. That's what you have to do. And that's what I do. I connect my monitors, I connect my modem, right? Internet modem and the computer. That's how I connect it. I don't need to connect more than that. Because those are the devices that I don't want to be without power. Everything else, can be without power because it doesn't affect my class, right? Send me, once you finish the exam, send me a chat message stating that you finished and you may leave. Okay, you don't even have to worry for my reply. You don't even have to worry for my reply. Just send me a chat message. Okay. So simultaneous access to Canvas and this Zoom link. You must be logged into Zoom and you must have your webcam on. Otherwise, you'll not be able to take the exam. If you don't have a working webcam in your computer, you can use the camera of your cell phone. So in this case, you're going to have, you will be connected to the Canvas through your computer, right? And then you will connect your cell phone to the Zoom link and turn on your camera, webcam in the cell phone. Make sure you have a reliable computer, a reliable internet connection, and a reliable internet connection. I also recommend an UPS device in case you lose power at your place. An interruptible power supply in case your power goes down once you go shopping. Okay. During the exam, your webcam, I already said that, right? Exam will start 8:50 and ends at 10:50, 2-hour exam. Once you finish the exam, send me a chat message stating that you finished. And after that, you may leave. You don't even have to wait for my reply, okay? Don't even have to wait for my reply. Makes things easier for everybody, even for me. You don't even have to wait for my reply. That's the instructions for the exam. Okay? Instructions for the exam. Here you go. Instructions for the exam.
Professor?
Yeah.
Are there any prep exam problems?
Any what?
Prep exam problems like
exam problem? Well,
like
the homework that you do in the book, right? Those are good practice problems for the exam as well as the examples, right? So here you go. The homework questions and the examples we do. Let's see, the homework questions, the examples in the book, the examples in the book, and the examples in the classroom, and the examples in the classroom are good problems. Are good problems to practice for the exam. Okay. So questions usually questions that I have in the exam are questions in the exam are either multiple choice questions or right? And or numerical answers. So you need So you will need a calculator, or you can even use an Excel or Excel spreadsheet in case you are familiar. In case you are familiar with the software to help you in numerical calculations. Okay. Numerical answers. So you need a calculator. So, you need a calculator or spreadsheet in case you're familiar with the software. In case you're familiar with the software to help you with the numerical calculation. Okay. Can we move forward now? What I want to tell you now, now going back to the lab, right? The lab report has two parts, right? The spreadsheet, and then you want to put between quotes here, hard copy. Not exactly a hard copy document that is prepared in Word, in Microsoft Word. Okay. These two documents must be uploaded to your group folder. I didn't think I covered the hard copy document, right? The Microsoft Word document with you, did I? Give me some feedback, please. Hard copy, yeah, I'm gonna explain. Okay, so apparently I didn't talk about that. It's a Microsoft Word document, okay? Yeah. This what I call a hard copy is a Microsoft Word document. Okay, and what's gonna be there? Let's take a look at the syllabus, okay? Syllabus, right in here. It's a very simple format, okay? It's not that involved. Here you go, laboratory report. Your lab report consists of two parts. I didn't cover that before, right? A spreadsheet, just exactly what we work with up to now, and a hard copy, which is a Microsoft Word file format. Which is a Microsoft Word file format. It is hard copy between quotes because nobody will print this document. Instead, you upload your electronic file to your group folder. Okay, and let's see what's the format of this document, right? Submit single lab report, Word plus Excel document, right? The spreadsheet contains the data, blah, blah, blah. The Word file is a document in the proper sense of a report. These two documents must be turned in the date announced by the instructor, usually before the beginning of the next experiment. The instructor will provide you with Excel spreadsheet with your data, which I did. This spreadsheet will be placed in the group folder that has already been created by the instructor. All group members must contribute to the preparation of the lab report, right? Your lab report is worth 100 points, and your grade will be based on the following. Every measurement and result must be reported in the main SI units and every possible combination of them. You will not report the units in centimeters, millimeters, gram, milligram, blah, 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 right? For every missing or incorrect unit, I will subtract 1 to 3 points from your report. The correct number of sequence figures, we covered that. Now, where is the go? There will be lab report format. Okay, here you go. That's the one. So-called hard copy. I have a sample here for you. I'm gonna show you. The top of a single title page. We're gonna use a title page. Center justify the following information separate by current you return. Physics lab report. Oh, that's physics 6 here. Physics lab report, physics 6. Laboratory number and title. Use laboratory number and title documented in the syllabus. In the syllabus, right? Not the experiment number in the lab manual. So let me give you a sample here. I have to go back to 2022 right here. Fall. Where is that? Huh. It's strange. Interesting. I'm puzzled. Okay, let's see. Let's see if I have some raw data. No. No. Okay, I have to go elsewhere to get you a sample lab report. For some reason, I don't have it here. Let me try another one. Oh yeah, here you go. Yeah, for some reason, I don't have the hard copy for the first one. Okay, it can be either a Word document or a PDF document, okay? But of course, you need to prepare this document. Of course, you're going to start with a Word document and then you convert it to a PDF. And let's see if we have a good sample here. Here you go. Physics lab report, physics 1, right? That's the title page. Then lab 1 is whatever. Here's lab 2. For some reason, I cannot find lab 1. And then the names of the students in alphabetical order by family name. You don't need to put student 1, 2, 3 here, okay? And what else? Group 2. Don't forget to put your group number. I need your group number there as well, right? So side by side. Let's take a look side by side here. Physics lab report, physics 6, laboratory number and title. Yeah, they put that's lab 2. Right, and the student name in alphabetical order by last name. By family name, not last name, by family name. List only the name of the student that participate in the lab activity, okay? So if a group member was missing from the lab activity, don't put that student name there. Group number, and they didn't put the date of performance here. Date of performance. For this first lab, put today as the date of performance. Okay, that's the first page. Okay, the next page, prepare a table with the original data and results. The table must be neat and well planned so the data can be easily grasped, include the proper units and sequence figures, okay? I'm gonna prepare one for you. Here you go. A sample here for you. New. And I will save it in your backup. College Harbor, go fall. And sample hard copy. Well, actually, the title of this document is going to be the same title that you used for your spreadsheet. P06 Lab 1, right? G, and then you put your group number, G1, G2. I'm going to put group 0 for me. Okay, but yours is going to be whatever group number you have. Okay, and that's the title page. center justify. Center justify. Let's copy. Physics laboratory lab report. Physics 6. Lab 1. And then we gotta do that. What's that? For the title. We're gonna look at the title there in the lab manual. Okay, I don't remember the title right now. What's the title of that in the lab manual? Someone can give some feedback on that. 6. Mesh, I think it's measurements, right? Measurements, right? And then you gotta, family name, first name, who will be student 1. I'm gonna put between square brackets. Square brackets. You don't put the student 1 in this title page, right? That should be student 2. You should have at most 3 students, right, per group. Student 3. Only those students who participate in the lab activity. And then you got a group number X, right? Date of performance, 09/27/2023. That's the first title page. That's the first page, which is the title page. Okay, the next page, insert a page break so you can start in the next page. And then what you're gonna do, you're going to just copy and paste the data in the tables that you have, right? This is good. It's gonna be the first table. It's not just copying and pasting. It's better that you also have to, to do some editing of those tables, right? You have to do some editing as well. I prefer that those cells be in regular space, right? And then we're gonna go for the other table. You need to spend some time, working on those tables. Let's see, here you go. Let's see if I can probably, let's see if I can, you know what? I'm going to use a snipping tool. Okay, and now I'm going to copy and paste right here. Make sure you don't have a small table there so I can see the numbers more easily, right? So here we have the raw data and the results. What else? Graphs, if any, must be neat. In the next page, prepare a table with the original data and any results. Here you go. The table must be neat and well planned so that it can easily be grasped, include the proper units and sequence figures. Graphs, if any. Okay, now we go ahead and copy and paste the graphs that the nice graphs that you came up with, right? Not those, exactly those, but 1, 2, 3, 4, 5 only. Yeah, I can see, let's see. Yeah, group number 5, right? See, group number 5, you didn't put all the data points there, right? For some reason, you didn't do that. That's because you don't have the mass here. Strange. Yeah, okay, so whatever happened here, I do not know what happened, right? There is a missing mass here. Check your group 5, check your original data sheet, okay? So here you go, I'm gonna copy, and can be also a snipping tool. No, you're gonna copy a better graph than that, right? Not this one. There will be a total of 3 graphs. This one, nope, not this one. Okay, this one. Oh, by the way, okay. The way is, let me rename that, okay? Sorry for the confusion here. I'm gonna follow exactly what is in the syllabus. Here you go. That's gonna be, save as, P06, right? Should be L, the title, 01, and G, use 2 digits. Use 2 digits. Just L, you don't have to spell out lab. Let's stick to what is in the syllabus. Right in here in the syllabus. P06, L, 2-digit number, G, 2-digit group number. 2-digit lab number, which will be 01, 2-digit group number. Okay? So that's how it looks like. Save it. Okay, and I'm working on that. Yeah. I think the name of the lab is measurements. Okay, Vanessa. Check the lab manual. Okay. And do I have my first graph? Yeah, here's my first graph, which again is not complete, right? And then you gotta paste the other 2 graphs, paste the other 2 graphs. Okay, next. Here you go. Graph, error analysis. What's considered error analysis? Error analysis considered the CL, the percentage difference, okay? And we will go there, here you go. Don't forget to, here you go again to snipping tool, highlight, copy, and paste. Okay. Right in here, right? And you do the same with the other one, the other table here. Of course, the table must be the completed table, and not just this table that is incomplete. Okay. Anything else? Here you go. Hard copy. And now then you're gonna save it, right? Save copy. Save. And then save as. You save it also as a PDF. You must, don't forget, both the Excel spreadsheet and this hard copy document must have exactly the same title, The only difference is going to be the extension, right? One is going to be PDF, the other is going to be Excel extension. And here you go. I have the document, the entire document in the so-called hard copy format. Okay. That's what I want to do. Any questions? So when you are ready to upload it, upload both documents. Okay. So after preparing everything, after preparing both the spreadsheet, the hard copy, upload them, the final, right? Preparing the final spreadsheet and hard copy. So we are transferring the Excel data to, yeah, that's right. That's right. We are transferring the Excel data to the hard copy. The only difference here that you are adding that title page, right? That's the only difference here. An actual real life experimental document, involves more than that. Okay, you have to explain how the experiment was performed, okay, what you used, but I'm skipping all of that just to make things simpler for everybody here. Okay, so after preparing the final spreadsheet, the hard copy and the hard copy, right? Upload them to your group folder. We have everything now to prepare your lab report. 10:55 right now. Any questions? So don't forget, it's due this, I think it's due is the 11th of October. Okay, we're done with this lab one, and we're gonna have a break now. Break, there's no questions, right? Now 10:55 a.m. to 11:10 a.m. And when we return, we will continue with the material for chapter 2. We're gonna have a lecture after this break. Okay? So see you in 15 minutes. Show screen. Okay, I'm back here and let's take a look. Okay, so we are done with the lab. Done with lab 1. Okay. And let's see where we stopped in the lecture. We stopped it right in here. Right? So what we did so far, vectorial representation. We did the summary of vectors, right? 1, vectorial representation, both graphical and mathematical, right? The mathematical representation is graphical representation is an arrow. The mathematical representation, letter with an arrow at the top. Okay. That's what we did. So operation with vectors. Operation with vectors. scalar multiplication with vector, scalar division with vectors, vectorial summation, vectorial subtraction. Okay? Those are the four vectorial operations that we cover, operations with vectors. Okay? The following operations are not allowed with vectors. What are the following? Simple multiplication between vectors, and by multiplication between vectors, and what do I mean? And then also regular multiplication between vectors, right? It's possible to multiply vectors, but it's not going to be a regular multiplication, okay? It's possible to multiply vectors, but it's not going to be a regular multiplication. It's going to be a different type of multiplication. So what do I mean about regular? And what do I mean about regular multiplication? I mean the following. Oops. I mean the following. You cannot have A multiplying B. Okay? You cannot have that. You cannot have that. And you cannot have regular, you can have other types of multiplication, but not the regular multiplication that we use for numbers. There's some special type of vectorial multiplication that we can do, but it's not this one, okay, that you see. And regular divisions, by regular division, what do I mean by regular division? Just something like that. You don't divide one vector by another one. You don't multiply a vector by another one. Okay. What else we look at? So graphical summation between vectors, right? We covered that. And then we discover how to get the resulting magnitude. Graphical summation and subtraction between vectors. And I'm gonna put here a okay, I can have my scalar multiplying a vector. Okay, that's allowed. I can have my scalar dividing a vector. That's also allowed. I can sum one vector with another. That also exists. There you go. A plus B. And I can have one vector subtracting the other. One vector subtracting the other. What else I cannot have? I cannot have a scalar dividing a vector either. Cannot have that. Can have a, oh, what did I do here? Interesting. I hate that when that happens. See, it's not behaving properly. Now let's try paste it. This is all the other. You can continue, but that trick Microsoft Word to accept to do what I want. Yeah, it shouldn't work, right? Vector cannot divide a scalar by a vector, okay? And I'm going to, like I said, you know, in order for Microsoft Word to do what you want, sometimes you have to trick it. Okay, now I got it. I finally got it. Here, something like that cannot be done. A scalar divided by a vector. And then again, you have graphical summation, subtraction between vectors, right? And there are two techniques, head to tail, and the parallelogram technique. Okay. The magnitude of the summation and subtraction in vectors. Action between vectors. Subtraction between two vectors, right? Can be obtained using the cosine law. That's what we covered. It's just a little review what we have done so far. We go. Cover all of that, right? Okay, so what else can we do? There's one more important thing that you have to know about vectors. Vectorial components. We didn't cover before. Vectorial components. New material, right? So you can have components of a given vector. If you come up with an x and y axis and you have a vector, let's start, you know, let's play the movie, right? I always like to play the movie. Suppose we have this vector A here. Okay. Vector A, vector A, vector A, here you go. Suppose that we have this vector A here in space. I can come up with a coordinate system, x and y axis, a Cartesian coordinate system, you know, and place this vector, the tail of this vector at the origin of the Cartesian coordinate system. Okay. The vector makes an angle theta with the x-axis, and by the way, I gotta label the axis, right? X and y axis. Let's play the movie, right? Right here, vector. Then we usually use a coordinate system, a Cartesian coordinate system. Can be other types of coordinate system too, but we are mostly concerned about that Cartesian coordinate system, X, right? I'm gonna make another, you know, just put the X here, right? Put it here. In the next one, I will label the X-axis. There you go. Right? Vector, x-axis labeled. And then we put the y-axis. And then we finally label the y-axis. Let's say this A vector makes an angle theta with the x-axis. Okay, what can we do with this vector? Okay, we can decompose this vector in terms of a component that's along the x-axis and a component that's along the y-axis. This is a very useful and convenient technique that we use to operate with vectors. Okay, that's a very convenient technique. Like I said, here you go. We can decompose this vector in terms of an x component. This one here, I'm going to label it as being the ax vector, a sub x vector, and the y component, that's going to be the a sub y vector. A sub y vector comes next, right here. And now you can write down as a, vector A as being equal to the summation of two vectors. One, oh gosh, this one's not doing it. Let's see. Okay, now it will do it. One along the x-axis, right? Plus another one along the y-axis. Make sense? Here you go. Looks just like that. We have the vector ax summed up to ay, that becomes the vector A. But we can do more than that. We can do more than that, okay? And that's where comes up something interesting. Okay, so here you go. We can define a unit vector, and we usually do that we call the x hat. Okay, this notation here, x hat, means a vector. Yeah, it is a vector. It doesn't have an arrow there. It has something else. There's a hat in there. And this hat, what does this hat means? This hat means that it is a vector, and on the top of that, the magnitude of x hat is 1. That's what this hat means. It means unit vector. Many books, call x hat, denote x hat as being I hat. Many books do that. I don't like that. Okay, later on we learned, we switched the notation. When I was an undergraduate student, all the professors would taught me this notation, right? And then later on, when I became a graduate student, this notation was abolished and they introduced us to this notation. There is no difference, right? It's just a different letter. And this,
Professor,
I think this notation is far more intuitive than the other one. Yeah.
so the x hat is magnitude?
Yeah, the magnitude of this is a vector, okay, represented by this arrow. And the magnitude of x hat, which is a unit vector, is equal to 1. Okay, I'm going to write that
okay.
down. I'm going to write that down here. The magnitude of x hat. I'm going to do this way. Oh, see, it didn't do the way I want. Let's see if it works now. Yeah, now it works. Magnitude equal to 1. Magnitude of x hat equal to 1. Oh, unit vector. Okay, I don't need that anymore. Let's play the movie again so you don't forget it. A vector we come up with an x-axis, and then we come up with a y-axis, two-dimensional coordinate system. So we can break down this vector into two components, right? This vector makes an angle theta with the x-axis. We break it down into component along the x-axis and another component along the y-axis. And it turns out, let me get that. It turns out, I need to introduce one more here. Okay. It turns out that the net vector is the x component plus its x component plus its y component. What else can we do? We can define a unit vector that lies along the x direction. By unit vector, I means what? I mean that the magnitude of x hat is 1. But I can do the same with the y direction. Okay, I can do the same here with the y direction. I'm going to copy that and paste here. And this is a very convenient notation because it allows you to do mathematical manipulations more easily. I can do the same with the y hat. The y hat also has a magnitude, of 1. Go. Y hat, magnitude 1. There's a reason why we're doing that. Why are we doing that? We're doing that because now we can write each of the components of this vector in terms of this unit vector. So AX now can be written down like that. A sub X, like a scalar, times X hat, okay? Because X hat has magnitude 1, now it doesn't change the length of the resulting vector. And we do the same for the y component. We go y component. All I have to do is to change. Like I said, it's a very useful technique that's used in math. It works very well. Okay. And now I'm going to go to the other nodes, right? Let's see if I need more than that. Let's see here. Let's play the movie first, right? Before we, yeah. A vector, x-axis, y-axis. X theta angle between the A vector and the x-axis, right? And then we have a x vector, a y vector. The A vector can be expressed as a sum of each of those two other vectors. But then we define also a unit vector along the x-axis. And the AX vector can be written down. Oh, something missed here. Yeah, interesting. This thing here is supposed to be elsewhere. Okay, here this way. AX vector is going to be AX component times AX scalar times a unit vector in the X direction. It applies both for the X and Y components. Okay, and let's see, we don't need that anymore, right? We don't need that anymore. We don't need that anymore. I will preserve that for now. Maybe you're going to need that. Oh, yeah. Okay. That's the next step now. I'm going to put that in my notes. Vectorial components. We can define let's see, we can express a given vector in terms of its components along the x and y axis, right? Like that. So if I have my A vector, I can express that in terms of x and y axis. And by the way, this can also be written in terms, not only in terms of a scalar, but in terms of also of a unit vector. Like that. But we can do even more than that. We can do even more than that. We can express those components in terms of this angle that you see right in here, right? And the vector itself. Let's do that together. Suppose that you know the magnitude of the vector A, you know the angle theta, okay? So this
Professor,
yeah.
I have a question.
Yeah.
So, you know that the equation you just wrote, like
Yeah.
so that's like a x naught times x hat, or
are you talking about the equation here in the PowerPoint or the equation in the Word document?
I think this is the PowerPoint. Oh, is it a Word? Let me.
Yeah, this one here?
Yes, that
okay,
one.
Okay. No, it's
So
AX, okay? It's AX, it's a scalar. It's not A naught.
Oh, okay.
Okay, it's AX. Okay, but I can also rewrite that in a different way, okay? Another way.
Okay.
I can rewrite that in terms of the magnitude of the vector A. Here you go. Magnitude of the vector A times a cosine of that angle that you saw before. Make sense? Theta, okay? Not just in terms of a cosine, but also in terms of a sine. Okay, but in terms of a sine as well. And now I don't need this guy anymore. Okay, 1, 2, 3 different ways of writing the same vector in terms of its component.
Okay.
Okay.
Thank you so much.
Welcome. Okay, and why do we do that? Because it becomes very convenient to do mathematical manipulations when you have a summation between vectors, for instance, right? So by the same token that I can have this vector A represented in this way, I can also have a vector B represented in this way. Here we go. And now it's not going to be theta. Let's say it's going to be theta prime, a different vector, a different angle. Okay. And that's exactly what I had in that PowerPoint. I have this vector B right in here, making a different angle with the x-axis. Okay. And I can sum those two vectors. Let's call this one the theta prime angle. I'm assuming that we know those angles. Oops. Yeah, I don't like that. Yeah. Oh, now I gotta do something about this prime. Let's see if I can change it somehow. Yeah, I managed. theta prime, angle theta prime. So if I'm going to sum up those two vectors, right, we are going to get this resulting vector C. Okay, and I'm going to copy this one here. A plus B is going to be equal to AX plus AY plus BX plus BY. Okay, which is going to be equal to scalar AX X hat, scalar AY Y hat, scalar BX X hat, scalar BY Y hat. And how do we here write that? Well, we can here write that just by collecting every X component. You know, I'm gonna commute this term, right? And I'm gonna put everything, I'm gonna factor all the X components into a single parenthesis. Okay. And we end up with something like that. We can go the next step too. The next step would be what? To write that in terms of the theta and theta prime, right? We can go the next step if we want. The next step would be something like that. Something like that. Something like that. And something like that. Okay. And we can come up with some examples, right? Let's example. Now we have a technique, a mathematical technique that's more straightforward to calculate the resulting vector. Instead of using the cosine laws, right? Instead of using the graphical representation, no, we're gonna do something like that, Let A, let's see, let A be at A equal, let's see, 5x hat and 7y hat, and B equal and equal to 1x hat, 10y hat, find, find A plus B. And by the way, I'm going to, so let's say A plus B is equal to a third vector C, right? Now we can say that whatever you have here is going to be the X component of C. And whatever you have here is going to be the Y component of C. We can make sense, right? Now we can do that as well. C can also be broken in X and Y components. Okay, we're going to solve it. Solution. So if you paid attention, right, you should be able to solve this example rather easily. Here you go. Just copy my A vector right here and sum it with the B vector right in here. And then we just do the regular mathematical summation, but it's gonna be the summation only between the same components. Okay, unlike components, different components, distinct components do not sum up with themselves. X hat component doesn't sum up with Y hat component. Okay, that would be the final vector C. Okay, and then we can go for the next example. Let be that find, now I'm going to ask you to find something else. I'm going to ask you to find the magnitude of the summation of those two vectors right here. And then we are going to have a solution. Look at how convenient is this notation. This notation is very convenient because it always provides you with a solution that are two vectors that are perpendicular to one another, right? Here you have one vector, here we have another vector, and they're both perpendicular to each other. So if I want to find out the magnitude of the two vectors, all I have to do is to apply the Pythagorean theorem. Don't have to worry about the cosine law, right? In order to apply the Pythagorean theorem, we use the equation for the Pythagorean theorem. 6 squared plus 17 squared. And you do the math. We can do that in Excel. Let's see what we get. 36 plus whatever, right? It's a big number here. 6 squared plus 17 squared. I'm getting 325. And then we have to take the square root of 325. It's 18.02. $325. 18.02. Like that. That's a type of example that you're going to see out there. Okay, then you can come up with, we can have another example, okay? I'm going to give you another example here. That, I'm not going to find A plus B. Find the angle that A plus B makes with the x-axis. Okay.
Professor,
Yeah.
I have a question. So what's the difference between example 1 and 2? Number 2 is just absolute value or something like that? Oh, okay.
That's right. Number 2 is a scalar, right? That's the difference here.
Scalar.
Number 2 is a scalar. This one here is
okay.
a vector. Do you see the final answer here? Here you go. I'm gonna boldface it, and I'm gonna boldface it. There's a difference between those two. Look at the magnitude here. Now I'm asking you what's gonna be the angle that this vector here or this vector here makes with the x-axis, right?
Yes.
You have to make now in this case you have to come up with an illustration. Okay, so here you go. I have sum up those two vectors. So one has a magnitude, or one has a component of 1, right? Let's go back there. One has a component of 6 along the x-axis. The other has a component of 17 along the y-axis, right? 6 and 17. 6 and 17. I want to know this angle here. I want to know this angle here. So what I'm gonna have, the 17 divided by 6 is going to be the tangent of theta prime, right? I'll call that theta 2 prime. Theta 2 prime. So copy and paste, right? I'll get the other one. Okay, theta 1 prime is here. Okay, theta 1 prime is here. I'm gonna take out the arrow there at the tip. Not cited position 1, I want something else. Format shape. Yeah, that's good. Okay. And now I have this other one here. The red one is going to be a different theta. I'll call this one. Oh, I hate that. Times new domain, times new Roman. Okay. And I'm going to illustrate it with red. I'm going to make it larger. So I'll put it aside. I'll make it red so you know that is related to the theta 2 prime. Bring it down here, right? This angle theta 2 prime is going to be this length, the y component. The tangent of this angle is going to be the y component divided by the x component. Okay, so what do we do? Tangent of, find the angle theta 2 prime. That a plus b makes it the x-axis. Okay, so going there, tangent theta 2 prime is equal to 17. No. Oh yeah, 17 divided by 6. No, don't want. I want. Erase this one here. Okay. And we can go another step, right? Let's do that in Excel. 17 divided by 6. I don't need that. 17 divided by 6. That's the number 28333. And then I want to get the arctangent of that. But that will be my result in radian. If I want to get it in degrees, all I have to do is to convert my radians in degrees is 70 degrees. 70.56 degrees. Okay. 2.8333. No. I'm going to close this one. I don't need anymore. From here, no, I don't need that anymore. See, we end up putting so many. This one, here you go. 2.8333. Okay. And now in order to find the theta prime, we have to take the inverse of this function arc And this angle end up being what? 70.56. Uh-oh. Ah. Oh, my keystroke now got lost here, unfortunately. Yeah, okay. So we have a little problem with this keystroke. Okay. That's a technique, mathematical technique. This is a mathematical technique that uses components. So your problem. Okay. Let's take a look at what we have covered so far in the book on this subject. Chapter 1, scalars and vectors. Okay. Vector addition, subtraction. We did that. And then components of vectors.
So the scalars and vectors part is not going to be included on exam, right?
No, on the first exam, no. In the second exam only. Okay,
thank you.
Of vector. And so now we finish chapter 1. Because we did also addition of vectors by means of components, right?
Yes.
So that's, oh, here you go. Tangency, same thing that I did here. Okay, 11:57 right now. So we finished chapter, and there's some homework there if you want to practice. At this point in time, I guess you want to concentrate for the exam, right? So we are done with chapter 1, right? Chapters 1 and 2 of the book. 1 and 2 of the book. Okay. And what you're going to do next, we're going to get into the kinematics of two-dimensional motion. Okay. 3-1, 3-2, 3-3, 3-4. Any questions? Not if I missed any of your chat messages here. Yeah, okay, no messages. Okay, so you can stop now. There's no message, you can stop now, and I'll see you next Monday, right?
I have some questions after class. Is that okay for you?
Yeah, go ahead.
Okay. So I have a question about instantaneous acceleration. So I don't know. So last night I was studying the previous lectures and notes, and I noticed that instantaneous acceleration was very similar to different coefficient. I mean different what's that called? Quotient, I think that's how I say. From calculus. So I applied I did the exact same thing. I mean I applied this formulas to solve the instantaneous acceleration, but I ended up getting like bunch of variable answer. As an answer, I got variables combined constant numbers. I didn't get the exact numbers with unit, you know what I mean? So I was wondering.
You gotta show me what you did. Would you like to share the screen with me? Do you have the?
I think I need to use my camera, but give me a second. I need to get my webcam. Oh wait, maybe I can just yeah. Oh wait. And I also want to know how to like solve instantaneous problems with different formulas and stuff. But I cannot find it. Oh yeah, okay. All right. I'm gonna. Do you see my screen?
It's out of focus. Out of focus.
Okay.
Yeah, it's still out of focus.
Oh, it's still not.
Yeah, it's still out of focus. It's difficult to.
It's difficult to.
Yeah, it's difficult to see. Well, give
Do
me
you
an
see?
example. So yeah, I cannot see it. Show me what's the statement of this problem.
Okay, so the statements of the problem was t squared minus 3t.
Minus 3t.
Yeah, but there was no given like any other like
But
detail.
where did you get this problem from?
It's just random website, but it's from
Oh,
institution like yeah, like university website. It's like I
okay.
was like looking
Do
for.
you have the link? Do you have the link?
Yeah, let me check it out. Hold on. So simply I typed. Yeah, I think it was this one.
Send me the
Yeah,
link
this.
in
Okay,
the chat window, please.
okay. So I think it was this one.
Okay.
So I noticed this that
I'm gonna share my screen with you, okay?
okay, I'm going to stop my video. That's not.
Okay, can you see it?
Yes.
Yeah, where is
Yeah,
that?
very first one.
Very first, so t square minus 3t. Yeah, see, he didn't put the units there, okay? The location, but that's a
So
math
is
problem. This is not a
so
physics
this
problem.
is like oh okay, so this is like calculus, right? I just need to apply
Yeah, this
t
is
every
calculus.
second.
Yeah, something
Oh,
like
okay,
that's
okay.
not going to show up in the exam. But wait a minute, let me see. Compute the instantaneous velocity of the object, the location. Yeah, okay, that should be x. You know, this something like that is not going to show up in the exam because it requires calculus. Okay,
Uh-huh.
and but we can solve that here. Uh, he put L instead of x.
Yeah.
Let me.
I think I get the answer, which is like 2t plus h minus 3. But I was wondering if you use this formula to find instantaneous acceleration, like how do you like apply units and all this like
Yeah.
stuff to this
Okay.
formula?
Okay, I'm gonna do that here for you.
Okay.
Okay, the situation is like that. The problem. He calls L of t, you know, that's unfortunate. We're calling that actually it's X location, right? No, the position. He meant the position. He used the word location, but it's actually the position, right? It's t squared
Okay.
minus 3t, 3t, right? So there's some units missing there. He didn't put all the units there
Right.
because it's so I know for a fact that he means 1 meter per second square times t squared, and he means 3 meters per second times t. Okay.
Oh, okay.
Okay. That those are the units that are missing in the problem that he didn't tell you. So he's asking you to find out the instantaneous velocity. Right?
Right.
Instantaneous velocity is going to be what? Just dx dt, right? But like I said, something like that is not going to show up in the problem, okay, in the exam, because it's calculus. Dx dt, which is going to end up being 2 meters per second squared t, 3 meters per second, okay? And then you apply the numerical value that he's asking you to do, right? T 7 seconds, 10 seconds, and a T. Okay, a T already have. Item C already have. A and B is 7 here, right? 7 seconds here. B is gonna be 10. Make sense? That's how you do. That's how you do.
That's all I need. Like I just need to plug in the given time number and
yeah.
But that's the instantaneous velocity formula.
Yeah, that's the instantaneous velocity formula.
Then how do you solve this problem without knowing calculus?
Without knowing calculus, there's some limiting that you can do. Okay, let's see. Here you go. Dx dt. Let me. Dx dt is equal to limit of delta x, right? Delta x over delta t, and I got right in here. Delta x going to 0, right? Going to 0. Delta t going to 0. Delta t going to 0. We can erase everything here. Okay.
So in order to do this, I need some types of delta x, like given delta x and delta t value, and just plug it in, right?
Yeah, so now you have the equation, right? Delta x here is going to be, don't forget x final minus x initial, right? X final minus x initial.
Displacement, right? Delta x.
Huh?
That's the displacement, right?
Yeah, that's displacement. X final is going to be this one here. No, let's say this one is going to be x initial. We call x initial, and then we put T naught. Don't forget to put T naught, right? And T naught to distinguish from the final. And that's going to be final. X final. Right? He's going to be T minus T naught. T minus T naught. Okay.
Okay.
And then what else can we do? Okay, T is going to be what? T is going to be T naught plus delta T. Make sense?
Yeah, but do I have to multiply by 1 meter over second square or?
Yeah.
Oh, okay.
Yeah, you have to multiply. Yeah, those. Okay, so do you have anything else? Okay, now we are going to expand that. Okay.
Okay.
Then we're going to do T naught square 2T naught delta T. And then we end up with delta T square. Okay, just regular algebra, right?
Okay.
Okay, so what else? Now, when delta T goes to 0, this term here goes to 0. Okay, notice that delta T squared is being divided by delta T, right? So whatever is left is going to be delta T. But you cannot say the same about this delta t here, because this delta t is going to be divided by delta t. Okay? So be careful how, this term disappears, because delta t is going to 0.
Only one, yeah.
Only the delta t
T
square goes to 0. Okay? Let's do that. Let's do this way. I'm gonna divide every term by delta t so you can see that better. Okay? Here you go.
Okay.
Delta t. Delta t. Oh, delta t. Delta t. Delta t. Delta t. Delta t. Delta. Oh, no, not here. It's a long calculation, okay?
Okay.
That's why we learn the shortcuts of calculus. A very lengthy calculation. Okay.
Okay.
So we go. This delta t cancels out with this delta t. This delta t cancels out. Delta t squared cancels out with the delta t, right? This one becomes 1. Okay, that I did everything I could have done, right? Okay. Next. That's going to be 1 meter square, 1 meter per second square. I'm going to put here 1 meter per second square, meter per second square, right? Yeah, this one, this one, this one. And let's see, we can do, okay, I can take this one completely out from the parentheses. Okay, note, see that this term here cancels out this term here, right?
Right.
Okay, so I'm gonna put it next. What else?
The
Not.
no.
What about this one here? Looks like this one. Yeah, looks like this one combined. Did I miss any negative sign along the way? It looks like I missed a negative sign along the way. 3 meters. No, I didn't. Interesting. They combine with one another. It looks like I missed some negative sign along the way. Oh yeah, I missed here, right in here. See that? I made a mistake here, right? So is a X, that's XF, that's X naught. Okay, here you go. Yeah. Okay. So I did use a negative sign here. It's gonna, this one here. Okay. This one here. Okay. This one here. Okay, and now, okay, what I'm gonna do, I'm gonna undo it here and just change the sign. This one end up, okay, plus. Yeah, now we have it right, yeah.
Professor, can you scroll up the, yeah, can one more? Let me see. Remind us. Oh yeah, this part.
You want more?
Oh yeah, now you can scroll down if you want to.
Okay, and now let's see. This one is okay. Okay, this one cancel out with this one definitely. Okay, and then we already did that. 1 meter per second T naught. I was supposed to be to put the 2 here, right? No. Okay, I will repeat this one. I will repeat this one. Let me erase this one here. 1 meter per second square. 1 meter per second square. 1 meter per second square. I'll take out this one from the parentheses. Paste here. Minus 3 meters per second. 3 meters per second minus 3 meters per second. I'll take this one outside, inside the parentheses, right, and paste it here. Okay, and now I'll go to the next step. Okay, those two. Now I'm gonna get those two only. This one right in here. And this one goes right in here, right? Just commuting. Those two disappear because they're right. Those two disappear as well. Whoa. Right? What about here? Okay. This one, this term goes to 0. Right? Because delta t is going to 0, this term that goes to 0. Okay. But now I wrote that down in terms of t naught. I have to rewrite in terms of t. Okay. And I have to rewrite in terms of t. It's going to be t minus delta t. And don't forget we're multiplying here. And then we end up, this guy disappeared, so delta t goes to 0, right? And that is gonna be our final answer.
Oh, okay.
Okay? It's gonna be our final answer. Just exactly like we did for our calculus, right? But we have to go through all this trouble to be, but if you memorize, if you do some shortcuts, you don't have to do all this work. This work took like 15 minutes for us to do.
Right. That's true.
This step by step.
Right.
Yeah. 15 minutes, almost 20. Almost 20. But that's how you do it without knowing calculus.
Oh.
That's
and I have other question. So let's say there's our like 3 different displacement. And there's like then how do you calculate velocity, like average velocity with 3 different displacement and 3 different time period of times? Like, how do you do that? Do I just need to use the first one and the last one as a x final and minus and the first one, or do I need to add?
What we're asking is similar to what we did last time, right? That you were asking me to do isn't that?
Yeah, sort of, but that one was like more complex. So I want to understand like the very like fundamental, like the baby step before I haven't solved that problem yet. So
well, you just it's more complex because you have a third vector in there. This problem sounds like a vectorial problem that you're asking, right?
Is it?
Yeah, there's 3 different displacements, and the displacement along different directions. Then it's a vectorial problem. Just like the one that we did last time. The one that we did last time also was a vectorial problem, but it was like 2 different displacements.
So when it comes to 3 displacement, more than 2 displacement, do I always need to use Pythagorean theorem, or I can just ignore the Pythagorean theorems to get the average velocity?
Well, I need to see the problem. Okay, I need to see the problem. And
I don't have any problem. It was just like imagination. Like
I know
I was
you're
just
yeah. Well, you have to do the drawing, right? Just like we did the drawing in the other one. I think I still have it. You have to do the drawing, and let's see if I have it here. Yeah, you have to do the drawing, and then you solve the problem accordingly. Do you remember? Let's see. Did we do the drawing before? We did the drawing before, didn't we?
yeah, we did.
I wonder if
And
I save it. Yeah, it doesn't look like I saved it because I cannot find it here.
oh, it's fine
Uh-huh.
if you didn't save it.
But
And
uh,
yeah,
but it's
and
similar.
about yeah, I'm sorry, I didn't mean to interrupt you. Go ahead.
Uh, it's similar to the other one.
Oh, it's similar to the other one.
Yeah, it's just one more vector there.
Mm. Then how do I do it? Do I need to just like start from the 1, 2, and then 2, 3, and get the total displacement? I mean like that, like 1, 1 and 2. Let's say first X and second X,
You should here.
X3, something like that.
Here, one vector, right?
Yeah.
Okay, and then a second vector,
Mm-hmm.
right? And then a third vector, head to tail, head to tail, head to tail, right?
Mm-hmm.
A third vector.
Mm-hmm.
The net vector is going to
Mm-hmm.
be this one. Okay?
Let's close this one, right?
Tail from the other to the head of tail from the first one to the head of the last one.
Mm-hmm.
That's how that's what's going to be the final result, right?
Right.
That's all. So that's all you have to do, right? So you sum one vector is the other one, this one.
Mm-hmm.
First vector is the second one, right? That's what you get. That's what you get. And then you sum this resulting vector is this third one, and then you get this one here. Tail to
Oh,
head.
okay.
Okay, that's how you do it.
Uh-huh.
Three different vectors. Okay.
Okay. All right. So from the exam, are we going to have instantaneous velocity, I mean acceleration problem as well?
Yeah, you should expect that. Everything that we cover. Yeah.
Can you show me an example if you don't mind?
Acceleration, you can go at the book. Here you go. Acceleration. You go. Mathematics, one dimension. Acceleration, right in here.
Okay, so that part, like which
Yeah.
problem did you refer?
The definition of acceleration. See that? Average
Okay.
acceleration. No, that's the definition. And you have an example. See that?
Uh-huh. Example
Acceleration.
3.
Huh?
Example 3.
Yeah, example 3. Yes.
Okay.
Okay.
Okay. All right, that's all I need to know. I mean, I solved the example problem last night,
Uh-huh.
but I wasn't too sure like if this was instantaneous acceleration problem or not, because this was like very simple question, you know.
Uh-huh.
So yeah, that's why I was wondering.
Uh-huh. Yeah, you gotta show me, no? But
Okay.
it's clear now, right?
Yes.
Cool.
All right. Thank you so much, Professor.
But
Have a wonderful day.
you too. Bye-bye.
Thank you.
Bye-bye. Log, log. E aí, César, o César enviou mensagem para você?
Já.
Respondeu?
Já.
Eu queria.
Ele.
Ah.
Não, é porque eu não respondi o Chico lá.
Tá bom.
E aí ele.
Tá bom, ele cobrou.
Ele falou que ele mandou o documento que ele tinha pro Chico, mas ele não sabe realmente o que o Chico tinha, o que o Chico estava querendo.
Aham.
Aí eu respondi para ele tudo.
Ok.
Eu tô conferindo as notas aqui para mandar pro Chico. Qual que eu não mandei ainda, tava lá. Isso que eu falei. Pedi desculpa por eu não ter respondido, porque eu não respondi mesmo.
Ok. Tá chovendo? Tá não, né?
Não, tá. Então, temporal lá em São Paulo, acabou, lá no Mário, acabou a energia. Acabou a energia, tudo. Chuva de granizo.
Uou.
Como diz minha vizinha, chuva de granito.
Granito.
Então, agora tá.
Granito realmente acaba.
Prepara acabar com tudo. Te falar, hein? Calma.
Lá em cima?
É.
Vai ser pronto.
Onde está substituído por uma de
Maior?
de 1.000 litros.
Não. E o outro? E vai para outra caixa d'água?
Não sei. Meu amor, isso eu nem. Eu vejo tanto mesmo. Mas a nossa.
Na hora. Fica subindo a caixa d'água lá para cima?
Não, aqui. Senta aí. Ai, eu preciso ver que meu cabelo tá feio. Hoje era dia de tintinho. Hoje não. É de...
Não, tá feita essa laranja.
É?
Tá.
Acho que eu não coloquei. Só fiz o suquinho. Tá azeda, tá bom. Falei,
Ai, como vai dormir. Ela entrou. This model is not. Marido ou eu? Não. Ronaldo, projeto. Não faz para mim, então, do teu ano.
Chega lá com o diploma daqui, fazer a
Não.
tem que fazer
Não.
provinha,
Medicina, dentista, direito, tudo.
contabilidade, eu pesquisei.
Contabilidade.
No meu conselho lá, eu tenho que fazer uma prova para poder ser contadora.
Convalidar.
É, eu pesquisei.
Física, engenharia não precisa disso. Não precisa ser uma profissão. Para que nem o CREA, né?
Mentira.
Você bota, está trabalhando de plano de limpeza.
Eu acho que você pega mentira. E só não está ganhando mais do que ela trabalha, ele vai viver. tem empresa e tem as sabe que essa pessoa está falando muito anos poucos. Isso. Esse, que hora vai vir? É aula de tempo, aquela lá que você fica ouvindo os vídeos
Eu vi no vídeo.
daquela indiana.
Indiana.
Era boa? Eu já tinha visto que assim, né?
Não, mas se assistir o vídeo, eu uso lá. Pra aula. Isso meio estranho. Ler. Deixa eu preparar. Preparar os sílabos que eu
Então, aquela aula tarde que você dava às 8 horas da noite não vai dar mais, né, amor?
É.